Have you ever played a sport and just felt a very huge pain afterward, and then you just realize you've just been sidelined? Or maybe you finished a workout and that kind of good story you had just turned into a much worse pain and it just won't go away. Physical therapy is cruel, and let's just be really honest here. Traditional rehab is very boring. It's just a static PDF of exercises and it's hard to track the progress, and most people just give up before they're actually healed. So we asked this question: what if your recovery felt as addictive and easy to use as your favorite social media feed? Introducing RecoverFeed, the TikTok that turns your rehabilitation into a premium, personalized, and interactive experience.
So you can navigate to our website using this link. And once you get to the website, it'll show you all the conditions for you to choose from ACL, shoulder, back, ankle, wrist, or even typing in another condition. For this one, we'll select ACL and press continue. And we'll select the phase in recovery that we're in, and this will generate a feed based on the intensity of exercises. We'll choose early recovery. And it'll generate a feed using OpenAI LLM call and use a search API tool to prevent hallucination and to also pull the best exercises for your condition. Once you land in your TikTok style feed, it'll show you all the exercises recommended for you to do for your condition. It'll show you tips on how to do them, why it helps, and the amount of recommended sets and reps per leg. And these are all generated by the OpenAI LLM call. And you can see tips on how to recover well during your certain phase of recovery that you chose. And you can see there's a bunch of exercises on different parts of the body pertaining to your condition. We'll go ahead and do this one. And so you can view a demo mode in case you're still confused on how to do the exercise. And you can see it shows a computer vision model using MediaPipe API, and it'll measure the degree change between each rep to count the amount of reps you're doing and score your form based on the range of motion. So you can see my lower range of motion scores as a bad rep or sometimes not even a rep, and my full extension, where you can see the degree change significantly, shows better form and a more complete rep. You can switch legs as well to also even it out on both sides and make sure you're doing a full exercise and set. And you can see live how a better rep is scored with a higher form, and me cheating the rep scores the form lower, and it does this over an average through my set. So we can complete the exercise, and if you like it, you can press the like button, and it'll call the OpenAI again and generate your more insights and show you more exercises that you liked. It'll show you more tips on nutrition, and it'll show you a bunch of exercises, and it'll show updating your feed based on what you've liked, exercises completed, and show you more exercises like that, show you more tips on even the mindset on how to recover. And you can also view your session stats, the amount of exercises completed, total reps, and average form score overall, and even XP earned. It starts with our onboarding. The user selects the injury and recovery phase, and that gets sent to our fast API backend, making a prompt to include their condition, phase, preference weights, and exercise history. GPT-4o Mini returns the cards back as a JSON, and each exercise comes back with a detection object with joint triplet nodes to highlight and measure resting angle, active angle, and form scoring thresholds. The LLM essentially configures our computer vision pipeline per exercise. That content flows into our usefeed hook, a custom React 19 hook that manages all state. It interleaves the exercise and knowledge cards into a scroll snap feed and detects which card is active. As the user interacts, our behavioral engine picks up on two types of signals: explicit ones like liking the exercise, saying it's too easy or too hard, and implicit ones such as dwell time and clicking interactions. Those signals update a 5-dimensional preference vector clamped between 0 and 1 with a learning rate of 0.1, and every 6 cards this updated vector gets sent back to the backend to regenerate the feed, continuously adapting. When a user taps try it, we load MediaPipe's pose landmarker as one shared instance, using WebAssembly or Wasm runtime and delegating to the GPU for smooth graphical processing, running entirely in the browser. It measures joint angles on landmark nodes and triplets and smooths it over a 5-frame sliding window to reduce jitter and shakiness, and drives a 3-phase state machine, resting, active, and resting again, to count the reps. Form is scored in real time against the angle thresholds for the exercise, all on your device. So why did we make this app, and what even is the relevance? From the data we found that 73% of PT patients fail to follow their home exercise programs. On top of this, it takes twice the amount of recovery time when patients don't do these exercises. This highlights the importance of staying consistent and putting patients on these home exercise programs, and also just making it fun and easy to do. It also, from the data, showed that 250,000 ACL injuries occurred per year in the US alone, and that's only ACL injuries. It's also proven that mobile apps and scrolling make the experience more fun and increase adherence by up to 40%.
All right, so we're now going to go ahead and talk about next steps. So there's a few things we want to improve on our website. So the first thing would be a machine learning model for improved learning. So right now the feed adapts is using just a simple preference vector, which is just simple math. The next step is that we want to create a real neural network that actually learns from everything. So like, how long are you lingering on a card? What do you like? Where are you skipping? And how well do you perform? The model will then get smarter the more you use it. The next thing we'd like to improve is the PT dashboard and the progress. So right now the app is patient facing, but the PTs need visibility too. So a companion dashboard where a therapist can see exactly what exercises their patient did and track their progress over the full recovery period and assign specific programs, all backed by the Supabase so the data persists. The next thing is we want to also do a social and accountability. So the research shows that one reason people quit home PT is isolation. No one holding them accountable. We want to add a Google Calendar integration so exercises get scheduled, streaks to build habits, XP rewards for motivation and optional PT. Check-ins via just a push notification. The last thing we really want to do is wearable integration. The webcam is great for a demo, but not practical everywhere. Pairing things like with an Apple Watch, or if the user has a Samsung device, this will create a resistance band. You can also use a resistance band sensor, which means that you can detect reps and forms in a gyms outside, hotel room, and anywhere a webcam isn't realistic.
Let's do a different exercise this time the bodyweight squat. As you can see, this computer vision model works across multiple exercises. I can do 2 good squats like you see here with decent form. Then I'll do a terrible squat with way too much depth in it, and it'll decrease my form score. Let's switch conditions to shoulder exercises just so we can prove to you how strong and accurate this computer vision model really is. Using the same LLM API call, you can see now it's generated many different exercises and tips for the shoulder condition. Let's go ahead and do one of these exercises.